funny from back here. All right, I am recording actually. So
hi everyone.
Those of you watching the video, it's a very
watch this.
interesting intro to the video. Today we are writing equations for parabolas. Again, this book calls it standard form, but we know it as vertex form. So I will always give you the formula. Y equals A times the quantity x minus h squared plus k. The biggest thing that people forget is to write the square. Do not forget to write the square. In this picture, they show us that the vertex is 1, 2. The vertex is hk. So they are telling you that h is 1 and k is 2. So put 1 in for h and put 2 in for k. Because the formula says x minus h, do you see how you ended up putting in -1 in the formula when the point is +1? Because in the formula and the vertex, that first number is always opposite. The next step is to pick another point on the parabola. Do you want to use 0, 0, or do you want to use 2, 0? 2, 0?
Let's make it difficult.
0, 0.
I think Philip's the only person who wants to use 2, 0.
It's no, so you might as well make it difficult.
Make it difficult. We're going to use 0, 0. So x is 0, y is 0. Put 0 in for y. Put 0 in for x. And now the only thing in the equation that we don't know is a. So we can do a little bit of math and figure out what a is. Start in your parentheses. 0 minus 1 is, and -1 squared, 1. 1 times a is a. To finish solving this, we would subtract 2 on both sides. So a is -2. Our educational system has kind of brainwashed you into thinking that once you get a equals -2, there, I solved it, I'm done. You aren't actually done. This problem says, write an equation. Don't just find a. A is part of the process. We need to go back to this step. Back to the step where we had the vertex in there. And now that we know what a is, we can write a in there. So y equals -2 times the quantity x minus 1 squared plus 2. Don't forget about the square on the parentheses. In example 2, we're doing the exact same thing, but this time instead of giving us a picture, they tell us the information. So your vertex is 2, 3. The point on the graph is 0, 4. I want you to pause the video, try this problem on your own, play when you think that you're done, and we will check it. Okay, first I put the vertex in, so this first line is putting the vertex in. Then the next line I put the point in. Keep in mind y equals, so you're putting the second part of that point in first, and then you're putting the x inside the parentheses. Don't forget about your square. 0 minus 2 squared is -2. 0 minus 2 is -2. -2 squared is +4. Subtract 3, divide by 4. We get a is not negative. A is 1/4. My brain's clearly not working right now. Take the form where you first put the vertex in and replace a. So y equals 1/4 times x minus 2 squared plus 3. Okay. A quick little extra thing to think about. What if the vertex was -4, -5? When you put the vertex in, you would do x minus, what is minus a negative 4. Positive 4, don't forget the square, and then plus a negative 5, which would be minus 5. So notice the vertex, the first part of the vertex is always opposite between the vertex and the equation. So that's just something to think about in case you encounter a vertex that has negatives in it. Okay, let's talk about this application problem. The first thing we're going to do is talk about where all of this information is going to come from. So the height y in feet of a ball thrown by a child is given by y equals negative 1/12 x squared plus 2x plus 4. X is the horizontal distance from where the ball is thrown. So I'm going to draw myself a little picture. So this kid's going to throw the ball and eventually it'll hit the ground. And it follows a parabolic path.
Parabolic.
X, so the horizontal distance, that's our X. And then the vertical distance, or the height of the ball, that would be the Y values. How high is the ball when it leaves the child's hand? That would be this point. If I throw this ball, the ball will be like 6.5 feet high when it leaves my hand, because I'm, kind of a giant. If a smaller person, since I'm recording, I won't call anybody out specifically.
Like me.
Okay, since he volunteered, if Philip throws the ball, it would leave his hand at 5.5 feet. There's a little bit of a difference between my height and Philip's height. So that height would be different. How high is the ball when it leaves the child's hand? That would be the y-intercept. So I want you to write next to each of these where this information comes from. And then down here, we will actually write the answers to each one. How high is the ball at its maximum height? The ball will be up here at its maximum height. What do we call that point on the parabola?
Vertex.
That is the vertex. Now, the first part of the vertex will take you horizontally to here. And then the second part of the vertex, if it doesn't jog over like that, the second part of the vertex will give you the actual height. So really, the number that we want is the second part of the vertex, the y value of the vertex. How far from the child does the ball strike the ground? The ball will strike the ground here. And we want to know this horizontal distance between the kid and the ball. Because that point is on the x-axis, x equals, take a look at the board, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We need to do the quadratic formula to find this value. All right, so let's start doing some of this. First, the y-intercept. What is the y-intercept of this equation? When it's written like this, the y-intercept is 4. So the ball will leave the child's hand at 4 feet above the ground. Part B. To find the vertex, we need to first do the opposite of b over 2a. So, negative 2 over 2 times negative 1/12. I would strongly suggest parentheses around the bottom part. Then you can do all of it just in one step. So, clear, dude. Clear. Negative 2 divided by parentheses 2 times negative 1 over 12. Close your parentheses. You should get 12. So our vertex is going to be 12 comma something. How do we get the other part of the vertex? Yes, plug 12 in. Negative 1/12 times 12 squared plus 2 times 12 plus 4, 16. And that's the number, oh my gosh, that's the number that we really want. So the ball will be 16 feet high at its maximum height. Now keep in mind, that means 12 feet in, the ball is 16 feet high. Part C, we need to do the quadratic formula. So I'm going to write it out. On a test, I would not give you something with negative 1/12 in it if I wanted you to do the quadratic formula, because I'm sorry, that's just cruel. X equals opposite of b, negative 2, plus or minus the square root of b squared, 2 squared, minus 4 times a, negative 1/12, times c, 4, all over 2 times a, negative 1/12. I'm going to show you some strategic laziness, strategery, whatever. Negative 2 plus square root 2 squared minus 4 times negative 1/12 times 4. Enter. Oh my gosh, I hit out of the program. That's so frustrating. Enter. Okay, now think about what I have. I have 0.309. I still need to divide by this 2 times negative 1/12. 2 times negative 1/12 is going to be negative. If I take what I have in my calculator divided by a negative number, I will get a negative answer. Do we want a negative distance as our answer?
Yes.
No, we don't.
What if we do it backwards?
So we need to do this with plus instead of minus. If you up arrow until that's highlighted and hit enter, it will re-enter it on your screen for you, and then you can arrow over and change that plus to a minus instead of retyping the whole thing. This gives me a negative, so if I do this divided by what the bottom is, which is going to be negative, it will give us our positive answer.
What's that weird ans?
That means answer. If you just hit divide, it keeps that answer in its memory and says the previous answer and then this other stuff. That's actually a really good question. No, that's a really good question, actually. 25.9 approximately. So the ball will be 25.9 feet away from the child. Now I want to show you a little bit of magic, because on a test, instead of saying how far exactly from the child does the ball strike the ground, I would ask you approximately how far from the child does the ball strike the ground. Because to get to this point, 12:16, we have to go 12 feet over and then 16 feet up. So if this piece is 12, what is this piece?
12.
12.
24.
It's really 12 only to about here. So from here to here is 24 feet. So the ball's going to go a little bit farther than 24 feet when it goes from like 4 feet up down to actually hitting the ground. But notice our answer was 25.9. So if I asked you approximately how far from the child does the ball strike the ground, then you wouldn't need to do the quadratic formula. You could just double the first part of the vertex to say, you know, approximately 24 feet away from the child, the ball is going to be hitting the ground.
Yes.
Yes. On your assignment, you're going to do 26 through 36 even. and number 56.